Okay, welcome back. We've got example number 3, which is a radical function. This should be a little more familiar because this is something that you did in early October, I believe, in 12A. So this is more or less a review more than anything else of some things that you've done earlier this semester. But let's get it started. So first of all, okay, we want to always start with a mapping notation because you are going to be given functions in transformational form. There would be rarely an exception to that rule. Definitely not at this point. So away we go. And this one's a little bit different because for the first time we see that there are two reflections. And also for the first time we see that there is a horizontal stretch. So notice here, okay, we would have x plus 3 instead of x minus 3. And this time out, like I said, there's a number in front of the x, which is new for the first time in example 3. So what we would do is we will flip that over. So that would be negative 1 over 2. And then the y values stay the same, which is just negative y plus 4. And that is the mapping notation. The key point, of course, originally 0, 0. Put that into the mapping notation, and we're going to wind up with 3, 4, and that is our new key point. So that's a good start. We could sketch that key point, and my x and y axes look a little squiggly right here, but we're going to just accept that and move right along. So positive 3, positive 4 is that point right there. And before I sketch this graph, okay, if you even decide to sketch it now, you may want to wait until you get all of the information, and that's a good technique as well. But what I'm going to do is I'm going to look at the two reflections. There's a negative on the x and a negative on the y in the mapping notation. So let's keep in mind that over here we have the original function, y is equal to the square root of x. So if it flips over the x-axis, and then it flips over the y-axis, it's going to go down and to the left. So I know that this graph is going to do something like this, but I don't exactly know where it's going to sketch the intercept the x and y axis. So I'm just going to leave it as it is for now, and I'm going to end up fine-tuning that graph as we proceed. So what we can do, though, is we do have enough information to get the domain and the range. So maybe we could do that part first. Or again, you could wait until you get a finished product and do it then. But it looks like horizontally, it goes from a minimum on the x-axis of negative infinity. It goes infinitely to the left. And on the right, it stops at a positive 3, including that point. So that is a square bracket. And then similarly on the y, it goes from negative infinity to positive 4. And away we go. We now have our domain and range. And next up, we can focus on getting x and y intercepts. So we could do y-intercept is generally what I start with first, usually a bit easier. And in this case, that is the case right here. So once again, okay, just plugging in 0 for x, doing the order of operations. So if I take a look at what's under the square root, I end up with a positive 6. Now, if you ever do this work and you end up with a negative number under the square root, you can stop right there, and that would mean that there is no y-intercept. But in this case, clearly there is a y-intercept because it moves down and to the left, so you know it's going to intercept the y-axis at some point. And in this case, it is a decimal. So what you can do from there is just use your calculator and get an approximate decimal number right here. And if we do the square root of 6, we're going to get 2 point something or other. And then we do this and we get 1 point something or other. Okay, I'm going to get a calculator. I'm going to do this officially. All right, I was going to take a guess. Oh yeah, 2.449. There's no real rule that says you have to do 3 decimal places. I'm sure 2 would be fine unless the instructions said otherwise. But hey, let's just make it super accurate here. So notice here, okay, you're going to end up with a value of 1.551. And the graph that I have drawn has a negative y-intercept. So we are going to switch that up in just a bit. But might as well find the x-intercept as well. So let's do that right about now. And this is a little bit trickier, but once again, okay, we're going to take our equation and we're going to plug in 0 for y. So I would have something like this right here, and solve for x, sorry. All right, so let's take a look at this right here. Okay, I need to get an x value. I plugged in 0 for y, so I can bring that positive 4 over, and it becomes a minus 4. And what I want to do here is I want to get the square root by itself. If there's a number in front of the square root, we would divide both sides by that number. Here, there kind of is a number. It's a negative 1. So if I divide both sides by negative 1, I now get positive 4 and positive negative 2x plus 6. See what I did there? I just distributed through the brackets underneath the square root symbol because we don't need to keep it in transformational form. We're just doing some algebra. We're not looking at graphing right here. So I get it this far, and then to get the square root, get rid of the square root, I want to get x by itself. So I can square both sides of this equation. Square 4, you get 16. Square square root, those two operations cancel each other, so you wind up with something like this. And now it's easy to solve for x. We can just bring things to the other side, so we end up with 2x is equal to negative 10, x is equal to negative 5, so we have an x-intercept of negative 5, 0. Now what we need to do is we need to go back here and we need to fix this up because clearly my graph does not have those properties. We have an x-intercept at negative 5. So I'm going to get rid of this graph and do something similar, but a bit different. And then we also found a y-intercept of 1.551. So I'm going to sketch what I think is that point right there. And then the graph is going to go something like that. Maybe that's not a really good graph, okay? Maybe it's not a good picture. However, okay, we can go to Desmos and check our solution. Okay, very recommended. And you'll notice right here, if you look at the solution, we do have those x and y intercepts. We do have this key point of 3, 4. Looks like we're all good here.